Thank you, Marian, and also thank you, Carbon Future, for this wonderful event today. So I start with a question. Did you know that demolition concrete is worldwide the biggest waste stream? Alone here in Switzerland, we produce 7 million tons of demolition concrete every year. Globally, we produce over 1 billion tons. So huge amounts. However, as Maurice from Silicate mentioned already this morning, the positive side of this enormous waste stream is that it can fix significant amount of CO2. And that's not all. There is also already a recycling industry in place that pre-processes this waste stream such that it has ideal properties to store the CO2. So this is why we at Neustark invented a technology that stores CO2 durably in demolition concrete. Sounds complicated? Well, it's not at all. Let's assume a concrete building, an old building, is teared down. These big chunks of demolition concrete are then brought to a recycler. The recycler crushes the chunks into aggregate. The aggregates are reused for road construction or, especially here in Switzerland, for the production of new concrete. Neustark just adds an additional step into this already existing value chain. So after the crushing process, the aggregate are filled in our reactor containers and brought into contact with a 100% CO2 atmosphere. What happens is that the CO2 reacts with the old cement phases of the concrete and is mineralized to limestone and therefore also durably stored. We measure precisely how much CO2 is taken up and certify the net removals through gold standard. But from where do we take the CO2? Today we source it from biogas plants that emit the CO2 as a waste stream of their biogas production process into the atmosphere. By liquefying the CO2 and transporting it to the concrete recycler, we can store it there with a net removal efficiency of 94%. So in other words, to store 1 ton of CO2, we only emit around 60 kilograms of CO2 equivalent along our entire value chain. Today, we have 7 plants in operation and several more plants that are being built. However, we know that our impact on the climate is insignificant if we store only a few hundreds, even a few thousand tons of CO2 per year. So this is why we set ourselves the bold goal to remove 1 million tons of CO2 annually by 2030. To reach this ambitious goal, we do not only need pioneering companies on the concrete recycling and on the CO2 source side, but also pioneering companies with ambitious net zero goals that help us scale, such as UBS or Microsoft. So this is why today I'm looking here for partners that want to turn with us this enormous waste stream into a meaningful carbon sink. Thanks a lot.
Thank you, Lisa. Well done. Now, the next startup that we have, Ucaneo, when we first met them, it really merited the term crazy, at least when we looked at the solution that they are developing. But they've progressed immensely since, and I'm happy for Florian to tell you more about this. Florian from Ucaneo.
Crazy, I think, is a lot of pressure, I would have to say. But first, thank you so much for having us here today, especially to Carbon Future. We're also part of the Carbon Future Catalyst and can definitely recommend any startup joining this. So my name is Florian, co-founder and CEO of Ucaneo Biotech. And we all know we have to remove CO2 from the air, but it's fucking hard, right? It's really difficult. And the main reason is because the CO2 concentration in the air is really low. It's only 0.04%. At Ucaneo, we believe like the most efficient way to restore a healthy atmosphere or to exactly remove CO2 at these low CO2 concentrations has evolved by nature over billions of years through evolution. Think about trees, plants, but also animals, humans, anything out there has really developed over all of these years. And some of these processes within the cell are like one of the fastest in the world of transporting selectively CO2. But if you think about an algae or a tree, it's not optimized to only remove CO2, right? It has better things to do. There's so many different functions a plant or algae has. It needs to live, it needs to grow. But we actually only want to have one function, really removing CO2 from the air. So what we do is We use the latest technologies in membrane technology, enzyme technology, and biotechnology to isolate the enzymes, which are the drivers of these processes, put them on a membrane, and put this in a machine. Sounds a bit sci-fi, a bit like a tree without a shell. If you can imagine that, maybe it's also a bad example, I'm not sure. But in the end, we imagined 35,000 trees on just 15 square meters. So we built first modular container-sized units, water-based, and can remove 400 to up to 940 tons per unit per year. Our strongest asset we have is really our team. Yeah? If you don't have the right team, you would probably not touch topics like that. We have more than 20 years joint research experience in material science, membrane technology, and enzyme engineering from institutions like Stanford, Technical University of Munich, or Max Planck Institute. Also more than 7 years of startup experience from leading biotech startups and organizations like McKinsey Leap. This all sounds great, but we're actually still very early, right? We're still a very risky project we do. We just started last year. We're currently 7 people. We're based in Berlin, have our lab there, our office there. We know the enzymes work, we know the functions, and we know, if you imagine it, we know in the cell, it's one of the fastest mechanisms in the world. But to make it the same work outside of the cell on an industrial membrane, that's really, really hard to crack. So imagine a bit like going from a soup, yeah, into a prototype. This is what we do right now. We're actually not fundraising, which is also maybe an exception. We don't need money right now, but we're looking for partners who can really help us accelerate the journey. That could be any kind of companies who are actually working on these topics, technological-wise, some membrane technology or chemical process engineering, but could also be companies helping us with marketing, project financing, or looking for future buyers. Please hit me up or just follow us on LinkedIn, ucaneo.com. Thank you very much and have a good day.
All right, last but not least, we're moving a bit closer home from Berlin to, not Basel, but to Zurich, with Stephanie Bischof from Airfix. Give it up for Stephanie.
So, good afternoon, everybody. And first of all, thank you, Hannes and the team, for an inspiring day. My name is Stephanie Bischof. I'm managing Airfix, a subsidiary of South Pole, predominantly acting in Switzerland due to our funding from the Migros Pioneer Fund, and we are focused on biomass, carbon removal and storage, i.e. taking the carbon from waste to energy plants, biogas plants or biomass plants. My background is actually in corporates, almost perfect saturated markets, and it was hard for me to imagine what it would look like when there is no market in place. Meanwhile, we got a fair share of wisdom, and we got some thinking behind how we can create value in this nascent stage of the market. I have 3 points here. Point number 1, we are supporting emitters along the value chain. This can be as early as assessing the potential at the beginning before even the project starts. But it can also be negotiating contracts for storage, for transportation, for monetization. Our first project is a biogas plant in Switzerland, which aims to permanently store its CO2 in the north of Europe. Point number 2, we aim to aggregate supply to optimize transport and storage solutions for emitters, and also demand by enabling long-term offtake contracts. We believe this is mainly relevant for smaller projects. Point number 3 is advocacy, so enabling the market conditions that are needed. And here we believe that it is very important to showcase a larger project, but really to create the right market conditions is what we need at the moment. And this is why we also recently wrote a paper where we outlined challenges that we see at the moment in Switzerland. The first challenge is that there is no liquid CDR market in place. So emitters face a situation of high cost, missing revenue models, uncovered risks, and this doesn't motivate them, of course, to get engaged in projects. One very good example of this is that a waste-to-energy plant, an average one, to take final investment decision would need more revenues than what we have actually made with tax CDR globally in 2022. I think this is quite a stunning fact. And the second issue that we see is the second challenge that we see is to connect emitters with storage. And why don't I say transportation? Because we could obviously also develop local storage opportunities, local use cases. Today, we do have some opportunities, but they're very expensive. And the network plan that we have in place, they don't enable us yet to reach the targets that we have set for post-2030. We have provided some solutions in the paper, and we now look forward to working on them over the next month and years, hopefully with some of you guys as well. And thank you now.